Once again, thank you very much for the organizer to have NVIDIA here as part of the keynote for the ROS conference or session over here. My name is Ettikan. I'm responsible for developer programs in the region. What is developer programs in NVIDIA? So we call everybody as a developer, regardless of a professor who got a $400 million funding or a startup who just started with a two-man team in the university dorm. All of them are developers. They are very, very important for NVIDIA because they power the innovation, they are foundation of innovation for us. So I'm going to share about what NVIDIA sees in terms of edge AI and robotics, a simple trend and outlook. Next, I'm going to go through some of the new applications, including, of course, all of us know about ChatGPT, how the large language model and Gen AI is impacting robotic space and simulation. Finally, I'll be covering a little bit about our work together with the ROS globally, and we are incorporating all of our SDKs and platform and libraries so that it enables all the developers to develop the application much easier, and some use cases towards the end. I know I have 50 minutes, just remind me so that I keep to the time, or else I can talk for hours. Because it's really exciting to work with developers, right? So we have seen the adoption of robotics gone into all verticals. Recently, Jetson mentioned, anything moves will be autonomous. And if it is autonomous, it is embedded, right? It has a capability to navigate, to operate, to perform operation by itself, and it is robotics, right? So we have seen huge adoption in manufacturing space. We have adoption in retail space in terms of automation in many, many areas in the retail. We have seen a smart city, healthcare, in terms of as simple as or as complex as robot-assisted surgery, right? Surgical robots, for example. There are many companies working together with NVIDIA building products for surgical robots. Logistics and warehouse, agriculture, the new wave of agriculture, we have seen many companies actually using an AI. And in Australia, I've been working with one of the developers. There are 4 team members, and one of them PhD in computer science. He said, I'm working on robotics for agriculture. I said, what are you doing? Right? It's exciting how they're bringing in AI and robotics and transforming agriculture in Australia. Home and metal and mining, where unmanned operation is very, very critical. We're working with some of these leading companies in the world. So robotics is going to be very, very important for the coming generation in terms of research and development and also productization, right? Why is it now and why is it edge AI? What we are saying is in terms of the networks, neural networks, in terms of AI, it's evolving and evolving very rapidly. LLM and Gen AI is actually I would say, assisting the developers to develop much faster and much easier. We are seeing in terms of the compute infrastructure, 5G, in some countries 6G is being deployed, access to the network. The robots could easily communicate back to the back end. There's another area. And then IoT devices becoming common in many verticals and areas which I shared earlier. Now, from compute capability, from single field function devices that we had, 10 teraops of capability was sufficient before this, right? For the fixed camera type of environment. But looking at more of complex devices, whether surgical robots or we are looking at warehouse logistics and all the way AMR, the compute capability required, it's humongous. We are looking at is more than 275 teraops, which is required because it has the capability of LiDAR, radar, multiple cameras, not one camera. There could be 4 cameras in a single robot and so forth. So we are designing our compute architecture to meet the needs of industry, right? This is some of the common challenges that we are observing among developers, right? Whether it is data is being collected in order to train the robot in a specific environment. For example, we work with many of the leading manufacturing, automotive especially, where they are automating the entire manufacturing lines, right? So where robots is very essential for them. So they collect huge amount of data set and they have to train the machine, not only in the simulation space, but teaching the machine to operate independently, but not too much of programming style of work, but teaching through AI so the robot can learn through examples and scenarios. Responsiveness has to be low. We have seen the requirement of 20 milliseconds or low. For example, in a critical area like surgical robots is very critical. Mobility, in order to scale, we are seeing environment where thousands of robots are operating in warehouses. And these thousands of robots has to work together, has to communicate, has to harmonize among themselves and organize in order to perform certain operation collectively. And deployment and management, of course, is an important task as well, as we have thousands of robots. So this is a simple illustration how we have observed from our compute platform, Jetson, the need required from one version to another version, or one generation to another generation, from Xavier to Orin. And we are pushing the boundary to increase the compute capability from one to another to almost 4.5 times much more compute capability to handle the LiDAR, the radar, the cameras, on top of all AI-related capability that's required. I'll go with you a bit more in terms of the capability of the compute. Anyway, you can get a Jetson to get started. It's a developer kit. You can just order online. Now, some of the features that we are put in as part of the complete stack, for example, it could be image segmentation, proximity segmentation, stereo disparity, for example. So this is what is the speed, what we able to do earlier, and this is what we could do now, sometimes more than 2 to 3 times better capability, so that you have more room to play with in your algorithm design and development, right? So this is Orin capability, and working with ROS community and also ROS developers, right? We are trying to streamline the operations of the whole workflow so that it uses less compute in terms of either CPU or GPU, and also reduces a lot of memory movement from the compute to the memory region. I'll go with you later a little bit, right? So from NVIDIA, we look at the robotic space as a complete cycle, right? You start with training the model. So we have a toolkit for you to do that, and these toolkits are free for you to download and use it. The next is, it is impossible to teach a robot for all possible combination of environment where the robot going to operate, right? It is much more complex to design a robot to work with the conditions where they may be, there's a human, non-human, and so forth, versus building an autonomous vehicle on the road, because there is a structured environment, right? So we see simulation is very critical. We have Isaac Sim as a dev kit. In order to build the robot, you need to have a lot of other tools to cover. I'm going to cover some of the tools over here. So we have what we call is Isaac ROS Jams. Together with the ROS community, we have integrated, validated, and then we have released it. It's a ROS1, ROS2 being supported. And finally, how do you deploy and manage? So this complete cycle is important as you go to production, right? That means you bring robotics for production. ROS simply, what we have done is we understand the complexity and challenges faced by developers, right? Because we are looking at real-time perception, real-time planning, navigation, object detection, and so forth. So this control has to be done with the millisecond type of accuracy, so that you could avoid certain complex scenario. You don't want to have a robot get into an accident in a certain environment, right? So we want to make sure that you have sufficient compute in order to control and manage the robot. Next is, if you look at it, it is a SoC, right? If you see many of the chipset that comes along, it has multiple interfaces and APIs and processes that you need to use. We want to make sure the developers have access to all these processes. Even in Jetson that we have a VIP, for example, we have encoder, decoder, and so forth. We allow the whole architecture exposed to you so that you can develop efficiently. And how do you navigate with fast-moving in the space of AI, for example, right? It's not easy to cope up with a lot of changes taking place, a lot of innovation coming through. The next is, there are many packages available, but not many are ready for production type of environment, right? How do you I would call it, harden the code before you get deployed in a production scale. So these are the challenges being faced. I won't go into detail of each and every component. What we are trying to do is having the hardware as one end. You can deploy it in Jetson, but you can develop on the workstations or server so that the same code can be deployed on the hardware itself. There is many accelerators given as well. For example, this is a VPI. Those who want to make sure you have 4 cameras or 6 cameras in a robot, and you want to efficiently manage the memory of the camera, whichever the camera that you're using from the industry out there, you want to compress it or you want to decompress it, you can do. Then it goes to many engines and servers. And finally, we provide a lot of software packages. For example, Visual Slam, for example, right? But there's many other packages that you can use, including the common packages that you can take it from any third-party applications, and then you can integrate. So that is our intent, to bring these ROS packages together to all the community. Today, we have close to 1 million developers in embedded space from NVIDIA, downloading all NVIDIA tools and libraries. So the value proposition of ROS and Isaac ROS from NVIDIA is what we look at is in terms of you can get access to a lot of work that we are doing. So NVIDIA has a dedicated engineering team, and we develop software components and library. But this team is very small compared to the rest of all the developers like yourself. So we want to make sure it is open source, open community, driven together. So we have different type of SDKs and libraries, and also source codes and algorithm we release. The next is we community, where we, as I shared with you, rather than having every code written on a CPU, talks to GPU and go back again, which is inefficient in terms of memory utilization, in terms of communication overhead, we try to bring that pipeline independent, the CPU pipeline independent of GPU pipeline, to improve the performance. Next is we put together the entire SDK and library, which is validated from NVIDIA perspective from all our algorithms, and it's open for you to use it for your own use cases and scenario. Now, I'm going to run through some examples, not all, because time is limited. So what we are trying to do is we want to make each and every software component that you're able to download from Isaac ROS, you can use it for your specific workflow. And this we made it as a code blocks, right? It's like a plugins, for example, code blocks which you can use it for specific purposes, and you can integrate together for different use cases and scenarios. For example, you want to integrate the camera into odometry for a specific wheel-based robot, or it could be leg-based robot, right? You can put that together to get one particular code block, which is called a nav2, for example, for navigation. That's how we structuredly develop the softwares and the libraries that we release and share with you. And we also share with you the performance of benchmarks that we tested in our lab, and it's available. So this is, for example, 3D scene reconstruction. If you want to reconstruct the 3D scene so that the robot could understand how, it's not only about object identification, it's about depth. You need to understand the moving objects. So understanding the depth is very critical. So how do you do 3D scene reconstruction? For example, you may have using VSLAM, or you're using as simple as people detection, people classification, or object detection, object classification, and so forth, and you bring it in as part of the one of the code block. We call it as NV blocks code block, and then you integrate together with many other plugins. So it has been modularized and easy for you to use to develop your own application. So this is in terms of map localization. So you want to do a mapping of the environment. You may use LiDAR, you may use radar, for example, or you want to use a point cloud by using your camera. It's up to you. And you can actually bring these codes and use it for your development work, including April Tech, for example, another library for localization and to understand, so the robot could know where exactly it is. So there is more code blocks like this that we have developed in terms of depth perception. Is another set of libraries for image manipulation that NVIDIA has developed. We made it free available. You can take, then you can put it into a complete block of code for you to achieve. Okay. For your development work, right? And finally, you can build these models together to bring cohesive model to do a specific operation. It could be grasping an object. It could be moving certain platforms, for example, right? It can be done. Same goes to a free space perception is another one area. Don't worry, I have the slides shared with the organizer. You can get the slides after this, and so forth, right? There's many code that we have developed. I just wanted to highlight to you today so that you know what you can take it, you can use it for your own pipeline that you're going to develop, right? Okay, then just to highlight to you, it is just not just the plugins and software code blocks that we are making available to all the developers. What we have done is we have actually worked together with the ROS community to make sure we make sure there's the ISAC platform. It's called, NITROS stands for NVIDIA ISAC Transport for ROS, which is validating all the transport, which basically is a message passing, communication between all the blocks validated so that when you deploy it, it is good enough for you to get started with your production ready platform that you're working on so that eventually you can harden it. So by using NITROS, which is NVIDIA ISAC Transport for ROS environment, by harmonizing all the communication between codes, rather than CPU to GPU back and forth, as I shared earlier, which is inefficient, you can get almost 3 times, or if it is not 7 times, the better performance, depends on whichever the hardware that you're choosing, whether Orin or it is a Xavier, right? The next is we also developed benchmark tools together with the ROS community. This comes as part of the ROS2 benchmark. So this benchmark will allows you to understand how the communication between all the blocks component, software block component, will allow you to understand where exactly, for example, a bottleneck, why certain communication takes longer than usual, right? Or how can you optimize further? So the benchmark controller that NVIDIA has developed and make it available, you can use it as a simple plugin so that you can evaluate the code that you have developed, understand the bottleneck area so that you can actually optimize it further. So this is a software 2 of ISAC ROS that we have released. It allows you more than just developing the code, optimizing the code, or benchmarking the code, even for the deployment, right? For example, you can use Jenkins if you want to organize and structure your test development, test methodology, testing cycle, and so forth. And then we have seen robot is not necessarily only at the edge. The pipelines of managing the robots and also the services where the cloud is essential part of managing the robots. So some part of the pipeline or the code may run in the cloud, and the other part may run in the robotics environment, in the robot itself, embedded, right? So the cloud and edge has to work together. That's why the 20 millisecond latency is very important, because part of their workflow for the robot management runs in a cloud. The other part runs at the edge. So we make sure that it actually structured such a way that not only you can use Jenkins in terms of operating and managing all your source codes. It is, we containerize it, Dockerize it so that you can use, those who are familiar with the Kubernetes, it is one of the area to manage workflow in a cloud, right? So it's easy to manage your entire deployment cycle as well. Now, briefly, I want to touch a trend. I won't go into detail. In terms of Gen AI and LLM, we have seen the impact in every industry and vertical. It is not anymore generalized models, but it's becoming a subdomain specific models, including in robotics. What we have seen is you can combine any of these components over here, and you can create another output from here. So for example, text and audio you put together, then you can create a model to automatically to create an audio for a given text, right? Or you can actually put in combining, for example, large multi-model complexity. You can create a video by just using a text. You tell, I want a dog which flies 3,000 feet above Singapore River, for example, right? Then dog will fly. With, you can see Singapore River at the bottom. You can see all the HDBs and building blocks down there, right? It's localized, contextualized for Singapore, for example, right? So it is anything to anything moment. And what we are seeing is, so we ask ChatGPT, it'll give you what is generative AI. But I'm interested more in terms of what is in robotic space. But two key invention, right, for the Gen AI and LLM is a transformer, and the other one is diffusion models, right? Transfer models and diffusion models. As you know, those who are already working in the space of AI, transfer models where is the prediction layer and attention layer, right? How, for example, ChatGPT 3 was built based on 95, if I'm not mistaken, layers of transformers. One is to predict one layer, right? So it is one is will predict what it is. Next, it will generate the content, right? So with this continuous improvisation, that's how a very good language structure can be generated by using large amount of data set. Same as in terms of diffusion model. For example, stable diffusion, Midjourney, NVIDIA has Edify, for example. It uses a noisy data set. It can actually construct a very good high resolution, eye-easing type of images by using diffusion techniques and model, right? Because it's been trained with a large amount of data set. So this too has a big impact in robotic space, right? Again, just to remind you, foundation model not necessarily must be generative AI model. Some of the models may not be generative AI, but still can be a foundation model to train some of these components. So when I ask ChatGPT, what is generative AI in robotics, right? So it is highlighted, these are the 4 key areas. I'm going to cover some of the 4 key areas as instructed by ChatGPT, right? So it says motion planning is important, control is important, simulation important, training is important, object recognition is important, human-robot interaction is important, according to ChatGPT. So I'm going to cover some of it based on ChatGPT, right? So what we have seen is a language part is very important, where we are seeing people are using just now when Maria gave an instruction to the robot, I assume the robot listened to Maria and then moved to the specific location. So the speech to text to speech is very important component. So the language comes in where the large language model being used in order to communicate to robot. Next is in terms of images and video. For example, next patch of images, if the image is missing, can I reconstruct the image? How can I create more images to train the models, for example? In terms of control and operation, we have seen the prediction of next robot action, for example. Some example of this I'll be sharing with you, how Gen AI can be adapted and used as a trend we have seen. Now, some of the challenges that we have seen in robotics today that can be assisted by Gen AI. So one of it is actually creating more data by using Gen AI. Next is in terms of environment diversity, how to train your robot in various environment, different scenarios that you may not even imagine or understood or even predicted, right? How can you simulate it by using Gen AI? Next is how can you program much easier for the robots, right? So these are the 3 key area we are observing. All the developers and companies are adopting Gen AI and LLM. One is in the space of simulation by synthetic data generation, augmentation of data, and so forth. Next is in terms of learning, so that the robot could be trained by using Gen AI dataset for visual learning, for control policy learning, right? And so forth. There's another area. And finally, very important is deployment. I'll cover a little bit in terms of deployment as well. So quickly, use cases for synthetic data generation, models like Stable Diffusion, Edify, DALL-E, which is developed by these companies are being used in order to create the data. So if you see each of the images may be slightly different, this much more eye-soothing and looks nice. I'm sure everybody wants to go for breakfast after this, right? So it's all synthetically created by generative AI, right? So imagine it's just an object we have given, for example, a photo of a plate at a restaurant table with the spaghetti and red sauce and so forth. That's the instruction given. Imagine if I can give this instruction in many forms and automatically, if I can use the LLM to create this instruction, and based on this instruction, I can create images. Imagine I can create a virtual scenario to train the robot for all possible conditions so that the robot is trained to manage it. So that is one synthetic data generation. Next is data augmentation. Now, most of the times we don't have enough data to train certain models and so forth. If I have a base data set, I can augment it in a way that I think is very important. So for example, you want to add a mask to the original image, or you want to add a Coke to the drawer, for example, right? So rather than the drawer doesn't have a Coke, I want to put a Coke inside here. I can add on easily, so you can augment the images. This is just an example of some of the work being done. So for example, this is a CMU and Meta has worked on a model called Cacti, ROS-I by Google and Google Research, GenOrg by University of Washington and Meta AI, and Modoco together with the University of Toronto, and also NVIDIA and Vector Institute. So this is an example of models being designed and developed for synthetic data augmentation. Next is virtual world design and development. So what we have seen is by using this synthetic data generation, we want to create a virtual world. So those are the objects created by SDG, and then you can augment it. So you have all the assets, and you can bring those assets into a synthetic, into a virtual world. And you want to make sure those objects are communicating. So you can have a graph network designed for those objects to, for example, to interact. The car moves along the line, or car does not move along the line. You can create multiple possible combination of those interaction between the objects in the virtual world, and you bring the virtual world in order to train by using Isaac Sim, the SDK I shared with you earlier, right? There's another area. Next is in terms of capturing the real world. So, we can, like for example, in autonomous vehicle, we drive a vehicle, we capture one virtual world and one specific environment. So let's say, for example, come to sunny and rainy Singapore, right? So I can't create a rainy condition with the sunset coming in a different direction in a walking path of Singapore where the path is shared by robot and human being, and of course dogs and pets and so forth. So how can I create a situation? Those who are from Singapore, the road in Bishan is totally different than maybe in a CleanTech park, right? Where the shared space is used by everybody else. Now, I want to drive once and take a picture, but after I take the picture, which is real world, next I want to augment it with multiple objects. Maybe a frog is crossing a shared path. I should not accidentally kill the frog by stepping on it for the robot, right? I can create those in combining the virtual world, augmenting with this. So this is another area we have seen companies actually working on it. The other thing is 3D asset creation. Why is it 3D asset? I want to touch. The depth is very important for robots, right? So understanding the depth. So from 3D asset creation, you want to have the depth information also captured as you create your simulated environment. Next is in terms of texture generation. We have seen all these models, for example, texture, text fusion, some of these Gen AI models being used in order to create the texture, the reflection of the light, the surface and so forth, so that when you want to train the robot to do a specific operation, manipulation and so forth, you can train in a virtual environment with the 3D, with the texture type of information embedded in the model itself. Again, this is another two example of model for nerve and also instant NGP. Actually, if you can play the video, I'm not sure, there is a video actually rotate. So by using a static images of 10 images, you can actually create the entire scene in a dynamic environment, right? So the nerves allows you, the nerve is very simple. It's just a method of how does the light reaches to our eyes from a given object at a certain angle. So it's like a voxel of boxes where the information is being generated dynamically so that we see the car is actually rotating and we know what is the object of, what is the surface of this toy at any point of time it is being rotated, right? That's what the nerve does. Basically, it's calculation of lights reflecting to our eyes for a given surface that is given. So automatically you can create a 3D environment. Next is how do you create a virtual world by using a large language model, for example, right? So in this case, the user input is, this is the room where we meet our customers. Make sure there is a set of comfortable armchair, a sofa, and coffee table. So what happens is, this is LLM input, this is user input, and it creates a prompt for a ChatGPT, for example, and then that input actually used in objects of 3D, right? So these are the 3D objects maybe stored in the database. By using a keyword, it searches and brings the objects together, arranged automatically in a living room type of environment, right? So by using a large language model, you can create scenes by giving this text, right? It could be user input, or you can have many prompts, thousands of prompts, to create automatically different type of scenes. Assisting in terms of robot simulation. So it is being used, for example, developer assistance in terms of scene generation for simulation, right? We have seen in terms of scene editing and simulation. So this is an example of how large language model, another area it can be adopted. Next is in terms of robot learning. So these are some of the research work being done. This is a vision transformer, VIT, by Google, Clip by OpenAI, and then so this is segmentation former, and then Dino V2. I'm sure those who know about Dino V2. So the important part of Dino is it is not about just beautiful image creation, but Dino V2 gives you the depth, right? So automatically by using Dino V2, for example, you can create a depth image with a depth features and functionality, which then you can bring it into your simulation environment. So these are just a simple some example of research work that I gathered. It's not necessarily only these. I'm sure there are more universities and researchers are publishing more papers, but these are something which is very commonly cited in many of the journals and papers. Next is in terms of writing code for control and reward function, right? So these are developed using multitask transformers. So these transformers are not one single transformer, but multiple transformers were put together. So over here, this is a proc prompt. I don't know whether at the back there, can you click on the video? There is a video here which plays. So this is done together with the UCS and NVIDIA. So there is a prompt which is automatically generated, and it's a code blocks, right? Each of these code blocks, if you just mouse over, fine. So this one work we have done where they use it in order to control the operations of the robot. That's one example. Next is in terms of using a large language model to write code automatically, right? So if there is a bin, how do you compose? If you see a recycle bin, what is the instruction to be done? This code can be automatically generated by policy that can be instructed to the robot. The next is in terms of using a reward function. Usually, if we use large language model, LLM, to generate an input, and then we tell the instruction, and then the robot will do. For example, the LLM says stand up, then the robot may stand up. But what the researcher is trying to do is, rather than using just straight large language model, can I use, for example, RL, right? Reinforcement learning. So by giving certain instruction, and if the robot behaves as it is, then you have a reward for the robot. So using LLM, bringing RL into the picture, you can train the robot much better and faster way, right? So this is an example of how LLM being used for multi-transformer type of environment. Next is in terms of control and policy. We have seen some of this work being done by Gato, Google, RT1, RT2 in terms of DeepMind, and RVT from NVIDIA in order to bring control policies by using multi-transformers task, multitask transformers. Next is in terms of interaction following certain type of instruction given, right? So Tidy Robot, for example, this by Princeton University and Stanford. So it is actually giving instruction. So this can be used by LLM to give instruction, and then how the robot actually adopts the instruction. That's another area we are observing, the adapting in order to teach the robot. So rather than coding and instructing and rule-based techniques and method, you can use LLM to keep the instruction going to train the robots. Next is say and can. Basically, it is by talking, and you can actually give instructions rather than only text-based instruction. And then Palm E, another work done by together with NVIDIA, where in this environment we use Edify model so that we could actually use the 3D objects and then navigate or instruct the robots to do operation based on the 3D objects which is placed on the table, right? Motion generation is another example. Again, it uses diffusion policy, diffusion model. As you know, diffusion is a method of creating high resolution or good resolution images with a very noisy image, which is diffusion techniques, all right? So rather than using just image, this is about a controlled movement for an object. So the image itself can be used in order to create movement of the object, right? Let's say the object were to move, how does it look like, which is automatically generated by Gen AI. And movement of the objects, which is generated by Gen AI, can be then used in order to train the robot, right? So rather than you have a human being trying to do each and every action to teach the robot, we use Gen AI then to train the robot by using this technique, right? It is similar to diffusion fields, which is called SC3 model by the Research Center. This is another method where you create this object not only on a pick. Let's say this is a pick and place, not only top down, but you can even sideways. So the creation of an object so that you can move the operation to put it into the cabinet as sideways is generated by Gen AI. So it's not only one direction, one dimension, but multiple dimension is possible, right? So what we are doing, a few more slides. What we are doing is we are trying to put this together in NVIDIA as a complete stack, so that you can use it for generation of simulation type of assets, or in order to create demos, or in order to create the supervised learning. This SDK is coming soon. In terms of deployment, quickly, we have seen this in terms of adoption, Gen AI for robotics programming, planning and navigation, and also human-robot interaction. These are the use cases how people are already adopting Gen AI and LLM, right? Some other use cases that we have seen, for example, this is Dino version 2, I think so, which we have seen. So rather than using a standard traditional deep learning method where we take an object, we segment the object, we bring the object, we train the deep learning model, whether CNN-based model, and then you deploy it, versus taking a Gen AI model automatically deployed for inference on the scenario, we have seen the true positive is almost 46 times versus traditionally designed and trained CNN type of model. Right? So it actually gives an impact in terms of accuracy. This is going to change the way that vision programming or vision processing, for example, going to take place. We have seen that in different other use cases as well, as simple as searching techniques by using Gen AI. So what we are seeing, the model Gen AI and LLM, I always get asked, is always a large model. The weights are big. It takes a lot of memory. Can I deploy it in a robot? So you need to distill the models. So distilling is something which is common. You can actually search for papers. There's a lot of papers being published in terms of distilling. It's just making the model much more smaller. You take the knowledge based on certain techniques that you could apply. It could be embedding techniques. You can be selection techniques and so forth. So you bring the large model. For example, we call it as a teacher model. From the teacher model, you reduce it by distilling based on your own techniques and algorithms and method. How do you want to distill and make it into a smaller model, which call it as a student model, so that you can deploy in an embedded environment. So this is so we have done this for using one of the model. Again, this model is publicly available. You can download, called Mobile SAM, which runs on 146 millisecond in order to get this model executed inferred in Orin Nano. But we made it into 27 millisecond on Orin Nano using called Nano SAM by distilling the large model to a smaller model or teacher model to student model. Right? This is just an example of companies already using generative AI in their own product. Right? Next is quickly some use cases in terms of farming, as I shared with you, is being adopted as well. Very different type of use cases being used. For example, they actually capture using a drone the whole image of the farm, and they bring the farm information, the videos information back to the simulation environment, and they simulate it to train the machinery which is going to operate in the farm. So it's quite interesting how the whole end-to-end cycle that I shared with you, done by a company called Vernon Robotics. Right? I won't go into details. The other one is Meituan, another company. This is a autonomous device over here. UGV, for example, they're using embedded Jetson as well. This is simple how they've incorporated not only edge embedded into the device, but as I shared with you, the cloud is very important as well. So the latency between the edge and the cloud is very, very critical, so that the robot able to communicate remotely to do certain type of operations, right? This is intelligent home robot. This is a company called Hackybot has actually implemented as well a simple adoption of the use of NVIDIA GPU and many of the software blocks and component integrated together for their own specific implementation. Another use case. Next is astronomical data processing as well. There's another illustration for you how it's been incorporated in terms of using a Jetson. Okay, this is a Skynode, another example. Don't worry, you have the slides. I just want to keep to the time. So coming back to conclude, the way that we look at robotic space is about you will be generating your own data set, whether it's synthetic, using some part of the real world, some is imaginary world or virtual world, some for objects, some for using SDG or augmentation or virtual scenario, virtual world generation. That's one. Next is you need to train the robot. After you train the robot, you eventually, of course, you got to build the robot. Physical part of it comes in, and then before finally you go to the deployment stage. So this is the whole cycle, and we want to make sure we enable the community. We have close to, if not mistaken, it's about 1 million people who are developing. So this is another example that we are working with the community to make sure that multiple blocks are put together to have the cloud component together with the robot could actually work. A toolkit called Tau, just search, you can download, it's free for you to use. We have 1+ million developers, and we have more than 6,000 customers actually adopting and deploying for production type of scale. And we have more than 150 partners working together with this. So it's an ecosystem that NVIDIA is supporting together. That is my last slide. Thank you very much for being patient.
Thank you, Dr. Ettikan, for the truly enlightening and thought-provoking talk. Now, we will open the floor for questions.
Yeah, I would like to, I'm Teng Sheng from S&T PPO. I would like to get a sense of when would synthetic video data production be possible. The reason I'm asking is because the government needs to test a lot of vendors' solution. For example, smoky vehicles emission. I don't know whether a vendor, when he proposed his solution, whether it works. And I need tons and tons of video images, and one way is I was thinking about whether I can synthesize this data for testing of vendors' solutions. Thank you.
Sure. So from NVIDIA, we have a few tools. So in the space of robotics, I would say it's called Isaac Sim. It's a simulator to simulate. And we adopt some of the Gen AI LLM in the latest release of Isaac Sim. You can bring it in. So you can take many methods that are shared with you, where you can create a scenario, right? And of course, we have another full-blown product for autonomous vehicle in terms of creating the whole drive environment synthetically, right? So the short answer is Isaac Sim. That's where you can get started with. You can put together so that you can create a scene, and continuous scene has been done. And there are developers already using it to create. If you ask me, complete, yeah, there are companies already producing 20 to 30 minutes of a cartoon, totally generated by Gen AI, right? For all kind of scenarios and use cases that you're doing. I'm sure that can be done for the use case that you look at. We can always talk about it in terms of your specific requirement and how we could actually help you on your journey. Okay.
Does anyone have any questions? Oh,
I think there's one here.
Hello, my name is Baniam. I'm from ROS-I. So I have two questions. So the first question is that for ROS, a lot of the times, sometimes we deal with mission critical and deterministic applications and behavior, especially if like some of the use cases you show on the lower end side. And that comes into question where like we have an AI model where, of course, based on data as well as the test set, we know for sure that maybe 70, 80, or even higher to like 99% of the chance it will follow whatever it's doing, but there could be that potential that it could do something else. That's like my question is that can AI address that determinism problem with regards to that?
Yeah, sure. I mean, it's a common question. It's a common problem, right? Since I'm using an AI, can AI be 100% foolproof, right? So the answer is you got to train, but enormous data set, that's one way. Next is you also need to have fail-proof techniques and method within the robot built-in, right? When it comes to a situation that it can't make a decision, you need to have probably a human operator operating somewhere else to control, right? To make decisions for the robot. So those kind of the techniques has to be brought in, because today AI is still quote unquote, for example, trained on a large amount of data set, and it may not have all possible data set that we could able to train the robot to make a decision for that particular instance, right? So that's where the fail-safe techniques and methods is to come in, to be adopted in the design of the robot for production use cases and scenarios.
Thanks a lot. And I think my follow-up question is also that like one of the things for ROS is that a lot of times ROS, we can switch between different kinds of algorithm from like heuristic based to AI based, and ROS is like the enabling framework for that. So as you mentioned, one of the things that you probably would like to see from ROS is like the failover for like ML based kind of algorithmic approach. Besides that, what are some of the enabling features within ROS that you see is the is the gaps to adopt more of the AI solution, or like bring the AI solution to a wider industrial use case?
Sure. So ROS is, it's an open source community. All of us are building together. And what we are trying to do is we want to make sure that code reusability exists. That's why we made it into a code block. And this code block can be easily used, and you can combine it with the different connectors or message passing techniques you're going to have in terms of the communication, right? Using the fundamental ROS capabilities. So what we encourage is more developers to contribute codes. But if you contribute a codes in a way that it's code blocks structured, like a plugins, then it'll ease many other developers as a community together. They may benefit from you, and then they also can contribute back to you, but make it into a code block, and this code block uses some kind of a standards using ROS community standards so that they can use it for their own pipeline. So my request will be create more code blocks, plugins, which can interact with existing plugins using standard interface, so that they can create meaningful different pipelines for different workflows and use cases and scenarios, and different IoT objects as well. Thank you.
I hope that has answered your question, Brandon. Thank you, Dr. Ettikan.
Thank you.